Somewhere over Florida, inside a sealed white room where the air itself is filtered 100 times cleaner than a hospital operating theater, technicians are running their final gloved hands across a piece of glass that could rewrite everything we think we know about the universe. It weighs 8,000 kilograms. It costs more than $4 billion. And in a matter of weeks, it will leave this planet forever, riding a column of fire toward a place in space where nothing has ever been built before. This is not another telescope. This is a machine designed to look at more of the universe in more detail in less time than any instrument humanity has ever launched. And the strange, unsettling truth is this: almost nobody is talking about it. While the world watches rockets rise and fall, while headlines chase the newest billionaire's spacecraft, a quieter revolution has been happening in a clean room in Maryland than in Florida, largely outside the public eye. Engineers have spent more than a decade building an eye for the cosmos, so powerful that scientists say it could find over 100,000 new worlds in a single mission. One instrument, one spacecraft, more planets than every telescope in the history of astronomy combined. If that sentence sounds impossible, that's because, until now, it was. Its name is the Nancy Grace Roman Space Telescope, and its story is not simply about optics and orbital mechanics. It is about a woman the world nearly forgot, a universe we have barely begun to see, and a countdown that is now, at last, down to its final days. To understand why this moment matters, you have to go back to a question that has haunted astronomers for almost a century. Look up at the night sky, and you see stars scattered like dust across the dark. It looks peaceful. It looks finished. It is neither. Every one of those points of light is a sun, and many of those suns, we now know, are circled by planets of their own. For most of human history, we could not prove that a single one of them existed. We could only imagine. Then, in 1995, everything changed. Astronomers detected the faint gravitational wobble of a star called 51 Pegasi, tugged ever so slightly by an unseen companion. It was the first confirmed planet orbiting a sun-like star beyond our own. A single world, glimpsed, inferred rather than seen. It took the tools of an entire scientific generation just to find one. In the 3 decades since, humanity has confirmed a few thousand more, one by one, world by world, each discovery a hard-won victory extracted from the noise of distant starlight. Now imagine an instrument that does not chase planets one at a time. Imagine an instrument built to find tens of thousands of them in a single continuous stare. That is the promise, and the burden, resting on the Nancy Grace Roman Space Telescope. But before you can understand what Roman will find, you have to understand who she was. Nancy Grace. Roman earned her doctorate in astronomy in 1949, at a moment when almost no doors in science were open to women. She earned one anyway. She went on to become NASA's first chief astronomer, the first woman to ever hold an executive position at the agency, long before Hubble ever launched, before most people in Washington believed a space telescope was even worth the astronomical price tag. Roman was the one who fought for it, defended it in front of skeptical committees, and helped drag the very idea of an observatory in orbit from fantasy into federal budget line. Colleagues would later give her an informal, affectionate title, the Mother of Hubble. Now, in the final months before this new telescope's launch, her name is stitched onto its hull, and the machine designed to be humanity's most powerful planet hunter carries her legacy into the dark. Roman's own telescope, though, is not a bigger version of Hubble. It is something stranger. It carries a primary mirror exactly the same size as Hubble's, 2.4 meters across, ground with the same extraordinary precision. But the resemblance ends there. Bolted behind that mirror is an instrument that changes the entire calculation. A camera built around a wide field detector, capturing images at roughly Thor photograph, a patch of sky up to 200 times larger than Hubble can see in a single exposure. Where Hubble must point, stare, and slowly stitch together 100 separate images, just to map one modest region of sky, Roman does it in one. A single frame, one breath, an area of space so vast that scientists describe its coming deep field images as containing hundreds of times more information than Hubble's most famous long exposure portraits of the early universe. Think about what that actually means. For 35 years, the deepest, most iconic image humanity has ever produced of the distant cosmos, the Hubble Ultra Deep Field. Oh, it has stood as a kind of sacred artifact, a single postage stamp patch of sky containing thousands of ancient galaxies frozen mid-formation, billions of years in the past. Astronomers have projected that a similar observation made by Roman would be every bit as sharp, reaching just as far back into cosmic history, but covering an area up to roughly 300 times larger. The same window into the beginning of everything, only flung open 300 times wider. And there is a second, entirely different instrument riding alongside the wide field camera. One built not to survey, but to hunt. It is called the coronagraph instrument, and its purpose borders on science fiction. to block out the light of a distant star so precisely, so surgically, that the faint, otherwise invisible glow of a planet orbiting that star can be seen directly, not inferred from a wobble, not guessed from a shadow crossing a stellar disk, seen, an actual photon of light reflected off an actual alien world traveling across trillions of miles of empty space to land on a detector built by human hands. If the coronagraph performs as engineers hope, it will be a proving ground for a technology future missions will need to directly image planets that might, one day, host life. For years, this machine existed only as blueprints, wiring diagrams, and increasingly anxious budget hearings. Now it is real. Technicians completed final assembly of the observatory in the clean rooms of NASA's Goddard Space Flight Center in Maryland, joining its two massive segments together. In a moment, engineers had been working toward for the better part of 2 that dwarfs every planet confirmed by every telescope in the history of astronomy combined. Some models push that estimate even further, suggesting the true number could fall anywhere between 60,000 and 200,000 worlds, depending on exactly how the survey is conducted. Let that settle for a moment. In the 3 decades since 51 Pegasi b, humanity confirmed a few thousand planets beyond our solar system through the painstaking labor of hundreds of astronomers and dozens of instruments. Roman may quietly triple, quadruple, perhaps increase that number by more than an order of magnitude in a single continuous observing campaign. And this is where the human mind starts to struggle with scale, because scattered somewhere among tens of thousands of undiscovered worlds could be exactly the kind of planet our species has been dreaming about since we first understood that other suns exist at all, a rocky world, the right distance from its star, liquid water poolings. On its surface, we do not know if such a place is waiting in Roman's data. Nobody does. That is precisely the point. For the first time, we will have a survey large enough and complete enough to start answering the question honestly, using statistics instead of hope. Out of all the stars in our galaxy, how there is a darker, stranger thread running through Roman's mission too. One astronomers discuss in quieter, more careful language: black holes. Scientists studying Roman's expected capabilities believe the telescope could reveal black holes in the act of tearing stars apart. Catastrophic events called tidal disruptions, in which the gravity of a black hole shreds an unlucky star that strays too close, briefly illuminating the darkness with the star's own dying light. Because Roman will stare continuously at enormous regions of sky for extended stretches of time, rather than glancing briefly the way most telescopes do, it is uniquely positioned to catch these violent, unpredictable flashes as they happen. Events that other instruments, simply looking in the wrong place at the wrong moment, would miss entirely. And then there's the strangest possibility of all, the one scientists almost never say out, loud without a careful qualifier attached, the discovery of something we are not expecting to find at all. Every time humanity has built an instrument powerful enough to see further, or in more detail, or across a wider swath of sky than any before it, the universe has answered. Not just by confirming what we hoped to find, but by revealing something nobody had predicted. Pulsars were found by accident. The cosmic microwave background, the ancient afterglow of the Big Bang itself, was discovered essentially by accident by 2 radio engineers who thought at first that the mysterious hiss in their antenna was caused by pigeon droppings. When you build a telescope that watches more of the sky more often and in more detail than anything that came before it, you are not simply confirming a hypothesis. You are opening a door and admitting you do not fully know what waits on the other side. None of this happens instantly. Once Roman separates from its rocket and begins its month-long journey out toward L2, engineers on the ground will spend weeks carefully unfolding the spacecraft, deploying its sunshield, powering up its instruments one delicate system at a time, and testing everything before a single scientific photon is officially collected. Mission scientists have described this process bluntly. In the days after launch, the team will be testing the observatory, opening its deployable aperture cover for the very first time, pointing it at the sky, and sending the very first trickle of real data back down to Earth. It is a nerve-wracking sequence, the same one that once made engineers around the world hold their breath during Webb's own harrowing deployment. Every hinge, every latch, every motor has to work exactly as designed in the freezing vacuum of deep space, with no possibility of a repair mission if something jams. If everything goes right, though, Roman is designed to keep watching for a very long time. Its primary mission is funded for 5 years, but engineers have built in enough propellant and enough redundancy that many on the team expect the telescope could keep operating for a decade or longer, a scientific instrument still delivering fresh discoveries about the universe well into the next decade of this century, quietly filling in the picture that Hubble sketched and Webb sharpened. Step back now and look at what humanity has actually built in orbit, or is about to. Hubble, still operating after more than 3 decades, gave us our first deep, sharp portrait of the visible universe. Close, intimate, extraordinarily detailed but narrow, like a keyhole. James Webb, staring in infrared from its own perch near L2, lets us see further back in time than ever before, past the glare of the earliest galaxies, into the literal dawn of cosmic history. But its view, too, is narrow, precise, almost surgical in its focus. Roman is neither of those things. Roman is the wide shot, the panorama. The instrument built not to stare intensely at one tiny patch of sky, but to survey enormous swaths of the universe all at once, catching the rare, the fleeting, and the statistically overwhelming in a single unbroken gaze. Individually, each of these telescopes is a marvel. Together, astronomers say, they form something greater, a coordinated fleet of eyes, each compensating for what the others cannot see, working in a kind of unplanned symphony to finally answer questions that have haunted our species, since the first humans looked up and wondered what, exactly, they were looking at. And Roman will not work alone, even among its living contemporaries. On the ground, a separate complementary observatory, the Vera Rubin Observatory in Chile, has recently begun its own vast optical survey of the sky. An instrument astronomers have already nicknamed the creator of the greatest cosmic movie ever filmed, repeatedly imaging the entire visible sky to catch anything that moves, flares, or changes. Where Rubin watches from the ground in visible light, Roman will watch from deep space in the infrared, the two surveys destined to be cross-referenced, layered, and combined in ways that will make each one more powerful than it could ever be alone. There is something almost poetic in the fact that a machine built to answer the largest questions in physics is also, quietly, a monument to a woman most people have never heard of. Nancy Grace Roman spent her career defending an idea that, at the time, sounded almost absurd, that the most important scientific instrument humanity could build might not be bigger or stronger or more expensive than anything before it, but simply positioned somewhere no atmosphere could ever blur its view. She fought for that idea before Hubble existed, before anyone had proof it would work, before there was a single image to point to as evidence she was right. She never lived to see her name attached to a telescope. She passed away in 2018, 2 years before NASA renamed the mission in her honor. But in a matter of days now, the machine bearing her name will leave the surface of this planet forever, climbing on a pillar of fire above the same coastline where humans first launched themselves toward the moon, and it will carry with it a promise she made possible, that the universe is not a fixed and finished thing, but something we are still actively, urgently learning to see. Somewhere out there, hidden in light that has been traveling toward Earth for years, decades, millions of years, there are worlds we have never imagined, events we cannot yet name, and answers to questions we have been asking since the very first human being looked up into a dark, star-scattered sky and wondered, quietly, desperately, whether we were the only ones looking back. In a matter of days, humanity will send an eye into the dark, powerful enough, perhaps, to finally find out. And when that eye opens for the first time, hovering nearly 1 million miles from every person who ever lived, the only honest thing anyone on Earth will be able to say is this: we do not yet know what it will see. That, more than any statistic, more than any specification, is the real reason the entire scientific world is holding its breath. Not because we know what Roman will find, but because, for the very first time in the history of our species, we finally have an instrument capable of finding out.